All right, class, I'm going to go over learning prompt 4. This was done by one of our classmates. Student did an excellent job. Um, so I just want to just briefly go over what you should be looking for when you're writing this write-up. I'm not going to really worry about what he's writing. I'm just going to kind of point out things. So when you're just looking at a variable all by itself, we do care about, the first quartile, third quartile, median, mean, but we're more kind of looking at like, what's the distribution look like? If the distribution is like just unimodal and symmetric, then it makes sense to just kind of talk about the median, first quartile, third quartile. But this particular distribution, it's really bimodal. It's kind of hard to really see, but it's like it goes up, kind of hits like a peak at 20, it drops back down, and then it rises back up at 40. Bimodality is the greatest feature that we see on this histogram. It supersedes like its importance of everything else. Because bimodality, when a statistician sees bimodality, two different peaks, it means that there's probably two unique populations inside of this sample of 424 people, because we're looking at all employed 20 to 21 year olds. And we're seeing bimodality. So that's the interesting thing. That's the thing that you want to notice, and the main thing that you want to point out. You could talk a little bit about, hey, these 20 to 21 year olds, but the more important thing is you've identified that there's probably two interesting different groups of people. There's interesting dynamics going on within these 424 people. And you see that on the next slide. When you break this group of 20 to 21 year olds into those in school and those not in school, you see vastly different histograms here. This histogram here, it has some weight, some density, less than 40, but it really shoots up at 40. And, if we actually did the math on this, but you could just say the density for those not in school at the bin around at 40. I don't know what this is. Is this 30 to 40? I think the bin's a little weird here. I'd have to look at the bin. Normally you want your bin to start at 0. I'm not totally sure it's starting at 0. It looks like it's a strange number. 1, 2, 3. Maybe they're using a bin width of 6. It's kind of odd to do something like 6. We usually want to do things like 5. So that's the only thing I've actually noticed on this student's work. It's really good, but I don't think I would have used 6 as my bin width. I probably would have used 5. Because this is kind of in a strange spot. But you're looking at this, you're seeing like pretty big differences. The median is 20 hours difference between in school and not in school. The mean is not as pronounced with a 12 hour difference. The spread, interquartile spread, like the width of the box is not very different. But you are seeing this thing of the median and third quartile both at 40. That's because we have a lot of people reporting 40 hours for not in school. So that's the main feature. That's what's making this big peak right here. It's because you have a lot of in-school people reporting 40 hours. So it's interesting to see that like this here is like the composition of these two functions. If you think about these as functions, this is the creation of these two if you actually were able to add them together. And then we later looked at if you're enrolled in school, is there a difference? So here, when I first look at this, I kind of just look at what's going on with the summary statistics. And median's not that different. First quartile's not dramatically different. Third quartile's identical. You look at the box plots, that's what it's showing. First quartiles, medians, third quartiles, not a whole lot difference. The men's first quartile is a little shifted to the right, 3 hours. And then the means are different. That's probably that's the major difference in the summary statistics, almost 24 hours on average versus 20 hours on average for females. But then we look at the histogram, we try to understand like why are we seeing a difference in means, but not that much of a difference in the quartiles. Well, when we examine this closer, looks like now this was 5, 10, 15, 20. So now the bin was set right at 5. I'll go over how to set the bins later. First, I'm just going to talk about this right now. So when I look at the histogram, what I'm looking for is when there's a difference in the bins. So you can see like this bin right here from 40 to 45, the density for females and males is about the same. But when we look at this bin here from 30 to 35, the density for the males is quite a bit higher than the females. It's over double, it looks like. And then when you look at this one at 20 to 25, there are more males in this bin. It's a little surprising that this little number is different. We would have kind of expected to see a trend that would continue for everything in the higher range, but we actually see that females and males are both as equally likely to work 40 hours or more, but males are more likely to work 30 to 35 and 20 to 25. And females are more likely in this range. But we also see on this side, when it's 0 to 5, 5 to 10, and 10 to 15, these only like 15-hour jobs, females are much more likely to be having these jobs than men. Men are more likely to have the 20 to 25, 30 to 35. Females are more likely to have the 10 to 15 hours a week versus 5 to 10 and so forth. So that's what I'm looking at here. But I think that the whole thing, if I was going to say this in general, very similar. The means are different, so it's like, why is that happening? When we do examine this, we see different densities at different regions in the histogram. And then for our last one, these are men and women that are not in school, but also 20 to 21 years age. And we see, again, the histograms, actually now we do see summary statistics are really getting kind of strange. We see first quartile is 20 versus 30. We see the medians now are actually 40 versus 30. So this is hard. Like, where is the median here? You actually have to go and look where the median is. So the median and the third quartile both, again, land at 40 because of the large percentage of men that are working full-time hours. But we do see, for both males and females, the most commonly reported time, or the mode for each of these graphs, is at 40 to 45 for both females and males. Females do have a higher percentage in this 10 to 35 range, but predominantly in the 20 to 30 range, they have a greater proportion of women working 20 to 30 hours opposed to men. Their density is a lot lower. This is the proportion of men, less. So I think in general, like you see also at 5 hours difference in the mean, so that would be critical. The medians are a difference of 10 hours. So I would say, if I come back to this one, the first thing I would probably comment on, both males and females have a mode at 40, but the males mode is a higher mode. A greater proportion of males are working 40 hours or 40 to 45 hours than females by a pretty significant amount. Beyond that, we do see that, there is a range of values. These men that are not in school, they are working between 6 and 60 hours. Females are working 8 to 42 hours. So we do see more males on the outliers on the right-hand side working extra hours, more than 40. But I think the main thing is, if you look here, you do see that the density of women are higher. I wouldn't really be that concerned under 20. I think it's more this region right here, this 20 to 30. So this is one difference, the 20 to 30 difference, and then also the 40 to 45 difference. And that is why we're seeing these summary statistics being different. The females are hitting their first quartile by the time they get to 20. Men don't hit their first quartile until they get to 30. And then females hit their median at 30. Men have to go to 40 to hit their median. All right, this was great work. Let me now go into the module and show you how to make the histograms properly. What we're looking at here is I'm going to go and I'll quickly get to the age. So we're looking at 20 to 21-year-olds. So it's interesting to note too that I chose a pretty tight age range. You want to do stuff like this because the dynamics of work and school, they change a lot as you get older. And people make decisions. Maybe their freshman year they got something going on when they're 18, 19. By the time they're like a junior or a senior, different circumstances are starting to evolve. So that's why we look specifically at 20 to 21-year-olds. It might have been better to look just at 20-year-olds because 21-year-olds, you're also getting students who are graduating already, which I was a little concerned about when I started to do this, but I left it as is. I think it would be interesting to filter out anyone who already has a degree. I was wondering, though, in this sample, what percent of people actually do have degrees? I was not expecting a whole lot, but maybe I could be wrong. 4% of the sample has a bachelor's degree. And if we looked at this, my guess is Is it different? That would be my only concern if it's like different by sex. This is kind of bonus little work here. 4% of the females have a bachelor's degree, 3.8% of the males. So these people already have degrees. These people already have associate's degrees, but they're not that vastly different. I think if I would have done this sample, if I would have done this homework again, well, I'll do it since I'm doing it right now. This might not help someone who's already looking to try to get the answers right, but I'm going to look at people who have not received any degree. They're still in college. They have less than a high school, or they have a GED. So these are our 19 to 21 year olds, or 20 to 21 year olds. Sample size is a lot smaller, but let's just see how this works. So the first question we looked at, if I remember right, was we wanted to look at hours worked. We wanted to compare it between those who. So I need to filter for employment status. As I'm looking at hours worked, I want to make sure they're working, and I wanted to compare those in school versus those not in school. So histogram, we're going to go hours worked per week. We're going to compare it by school enrollment, binary. We're going to use an overlay. We're going to set the bin width. We're going to go 0, 5, and we're going to go all the way up to 90 just in case. And we always want to do density. So this is my main story in class that I was saying is you have to do density when you're comparing two different groups. You should do an overlay because it's only two groups, but maybe a faceted could be possibly better. Bin width, you kind of have to experiment with. We found after experimentation that 5 was pretty good. You better type in a 0. If you don't type in a 0, it doesn't actually start. It'll start the bin at the first data point that comes into the sample. So you could get yourself in trouble. If one starts at 3 and the other one starts at 5, you're going to have bins that aren't going to be coordinated with one another. So as we generate this, it looks pretty similar to what we saw before. Not in school is much higher. This is about 50% of the sample. 50% of the not in school people are working 40 to 44 hours. Again, if you're in school, you're more likely to be working these like 24 hours or less per week. But there's still people in school that are working 30 to 34 and working full time. The next question we asked, I just was wondering about this one because we saw a pretty big difference. Let me see. So I want to look at people who aren't in school. So I want to go to not in school. Make sure that I filter it. Just because you selected it doesn't mean that it's filtered yet. So you'll see not filtered yet. So now when I create the filter, I do have it. And I can generate this again. I'm going to go by sex. So this was comparing men and women that were not in school. So I don't know if it changed a whole lot. I think we're still seeing sort of the same story. Females are more likely in the 25 to 30 range. Males are more likely in the 40 to 44 range. Again, on these, if you noticed, I was talking about too in the video, like, or in class, if you were in class, like I talked to 11, this is a 0.11 up here, and this is 0.8. If you multiply that by the bin width, the bin width is 5, you can get the true proportion, the percentage. So 8 times 5 is 40, so that's 0.4, that's 40%. 40% of the women that are not in school are working 40 to 44 hours. This is 11.3. For simplicity, we'll just say it's 11. 11 times 5 is 55, so 55% of the men are working 40 to 44 hours, and they don't have degrees. That's the interesting thing about this now, because I did a different sample. I filtered for people who did not have a degree yet, that were just going, they were in college. They had some college, or they didn't have any college. So that was that group for not in school. We could again look at how does it look for those in school. Create the filter data set. I'm just going to repeat that histogram. I think it was fine. So this is these are people are still in school, and we see that the males have greater density at 20 to 24, greater density at 30 to 34, not that much of a difference 40 to 44, and the women have greater densities between 0 and 14. When it says greater density, it means if you look at the female subgroup, there's a higher percentage of the women working these hours, basically 14 hours or less, compared to the percent of men that are working this 14 hours or less. That's what density means. Density is the proportion of people in the sample, but you have to multiply the density by the bin width to get the proportion. So this is like 3, this would be like 15%. Up here, this is 5.5, a little harder. Here's 4, 4 is nice, 4 times 5, 20%. 20% of the females in our sample were working 20 to 24 hours. All right, well, I hope that helps you on this assignment. Please reach out to me on anything that you need help on. I know there's some issues on like working everything in Google Sheets. There's a lot of things that can be giving you trouble. It doesn't hurt to just come into my office, sit down, go through a couple things, clarify any confusions that you have. I'm here to help you. So please take advantage of it. Take care. Have a great day.